There. How you doing? Oh, I have a mail. Just a sec. Never mind. Good news. Someone subscribed. I figured I might as well start on this now. I don't know how far I'll get. But this here video that I'm looking at is one I recorded. I think it was between the last two. And I didn't like it. But there are some bits and pieces in here that I wanted to try and cover that I didn't cover in the last two. And I think those things come out of this documentation. Basically, there are two documents I've been looking at. Not really books. This is something something online, and I just said save web page to disk. Well, I already got it there. And although this is it's part of something else, and it's talking about a particular thing called OS Kit. I don't know what OS Kit is, and I don't know what the main drive is of this page or article or book or whatever. But a few good points are made in here. And in fact, because this is on a web page, there's no way to mark anything, so I took some screenshots. Now, well, the first, I already mentioned this dynamic dispatch thing, right? And how that's similar to the C++ dynamic classes, you know, the ones that have all of their data in static read-only memory. And I showed you how that's also true of these dynamic dispatch tables. They're in static read-only memory. They don't change. So I thought that was kind of funny, at least. Dynamic dispatch. Now, we see there's something here I wanted to make a point about. So I've been showing you and been talking about objects and interfaces, which is all that COM is concerned about. Even use the word concern. A COM can be implemented in any language and can maintain its state in any way it chooses. The only relevant thing about the object, and there doesn't even have to be an object, is its interface. Well, there is an object. Okay, there is something that you could call an object, and the object is the thing that is identified by the class identifier, not interface identifier, class identifier. They're in the same format. There are those UUID numbers. This type of format, this program I think comes with the, where is that? Yeah, it comes with Visual Studio. And isn't that funny? Error again. Strange. What if it happens again? It's different every time. Now I think it's okay. I think what happens is I use it as an administrator, the batch file. and it always creates this temp file. And when I switch back to the regular me, it has less access for some reason, and then it also seems to get rid of it. Anyway, that's not what I wanted to talk about, but so the class IDs, like in our case, our server has a class ID, and this is its number. Okay, keyword, 2 words, and 8 bytes. That's a GUID. I think GUID stands for Globally Unique Identifier, something like that. They don't tell you. Well, Google, that's what Google's for, isn't it? I wish it would just be a regular Google every time. English. English Canada. Globally Unique Identifier. There you go. GU and ID is for one word. Yeah, those numbers, of course, are a great big pain because to look at them, they're meaningless, right? So it's hard to find out what things are just by looking. But anyway, so there was that point. The other point, I think I made this point at some point in time. And this comes from the other document that I've been looking at occasionally. Actually I got it down here. I found this online. I might as well try and find out what it's called so you can get it. Visual C plus MFC 23 decon. Okay, so I don't know what the name of it is. It's called, just labeled the component object model. But this is quite an old article. It was probably published in the 90s or something like that. Let's see, maybe at the bottom, maybe a date. None of these links are any good. And you see that the main thrust here is MFC, right? Where nowadays MFC is passé. Nobody uses MFC anymore. That's, or COM. There's no COM plus. So we have GDI plus, but I don't think there's a COM plus. Not that I've heard of. But anyway, it's good. This is a good source, though, just for some of the terminology, and also for some of the principles that describe what COM is meant for. And this thing has a highlight tool, so I can highlight some things. This was the point. The COM, component object model, is a protocol that connects one software thingy with another and then drops out of the picture. After the connection is made, the two things communicate through a mechanism called an interface, right? We know what that is now, sort of. It's something that's defined by those dynamic dispatch tables. right? There's no static or dynamic linking, no hard-coded addresses, and so on. Now, here's the thing that caught my interest about this article is the way that they're comparing COM and C++ and showing how they're different. And that also has to do with, well, speaking of this difference, has a lot to do with the problem of that diamond, the diamond problem. The reason you end up with a diamond problem, or that people end up with a diamond problem, is because they don't understand what C++ inheritance is, right? Like, whatever the example was, I guess I've lost it now with the bat. The pictures are good. When a C++ class inherits from another, let's say we represent a class as a box, right? Text, red, oh, derive, say, bigger. When a derived class inherits from a base, hang on. Okay, so it's easier to just stop the recorder and let things run at normal speed to do that. So now here's a visual kind of view of inheritance in C++. We have class D and a class B, and D derives from B, right? Now the idea is that we think of that now D has inherited all of the properties of B, and and its methods and actions and so on. It is, in fact, it behaves in every way like a B with some differences, right? Now, what I just described to you is more like COM inheritance. That is, inheriting the properties of this object. But C++ inheritance doesn't just give you the properties of B. It also gives you the data as well, because the data and the code in C++ are tightly bound. That's one of the goals of C++, is tighter binding of code and data, right? So to getting into the diamond problem, if I can do that easily, if you have that B there, there's another class, A, black lines. If we think of, if we're thinking in terms of inheritance of just properties, right? So, as in the example, a mammal and a winged animal or something, right? If all we inherited were those properties, then this model is fine. We don't have a problem. But we don't inherit just the properties. We also inherit all of the data, all of the specifics. So this is there can only ever be one. This A here thing represents a complete object, right? It's not a part of something else. Similarly for B. So to combine things in this way in C++ is generally not correct. It's generally not the thing that you would want to do, right? And that's why you end up with the diamond problem. And the fix for it, if these two things happen to have a common ancestor, the virtual derivation, is to me that's a hack solution. I would say that's a hack. That is, you've got a problem, and so to get out of the problem, since there's no way out of it by the design of the language, they have to invent a hack, a workaround, so that you can use C++ in a way that it wasn't intended to be used. But COM is intended to be used in a way like this. This is okay in COM because of this fact, and it's stated in one of these documents here. That's what I was trying to get to. One of the main goals of COM is to separate a class as an interface from its implementation. Well, that also means separation from data, right? So now he starts talking about C++, and this comment follows this one. The most interesting feature of they invent a thing called a spaceship. As an example, as this article continues, they build a spaceship and different things about it. It says here is that the interface of the C++ class and the implementation are tightly bound. They're not separable, really. Okay, and I would also add data. And COM, one of COM's goals is to separate implementation from interface and only concern ourselves with interface, and that is only the behaviors of things is important. And there's a word for this too. This reminds me of it. This class object that they're talking about is the one I mentioned. The one identified, and there's only ever one, I think. You could, I guess, have a DLL with two classes, but they would be separate. There wouldn't be any connection between them. This class is what's being referred to here, is something called a meta class. Okay, and the way to think of a meta class, I suppose, is that it's like a classification, right? I mean, part of the problem with C++ is the use of the word class when these are just structs. Okay, if they kept it as struct, this wouldn't happen probably as often anyway, because of the language wording, we think of a class as a type of category, but it's not. A C++ class is not a category, right? It's a specific object. It's not a meta anything. You could invent a class that acts as a classification type object, and it's possible. The language allows for it. You could write com using C++, um, but that's not the way it's usually used. Now, the other article mentions something else, a word that I wanted to. Oh yes, here we go. Now, speaking of inheritance and this I unknown. Okay. Now, there is something like inheritance in com. I just inferred that by saying you can do this sort of thing in with com. But it's totally unlike C++ inheritance. Now you could do that by adding more methods to the dispatch table. So for instance, if you had our math object that squares and cubes, if we wanted to extend that class, we could add plus and minus, right? So we would add more methods to the dispatch table. But there's a catch, and that should be said somewhere here. Com has very strict requirements when it comes to the interfaces. Derived interfaces cannot weaken the requirements of the base. That would violate the principle of subtyping. Okay, that's the word I was trying to find. Subtyping. That's what com does. It's inheritance. Its form of inheritance is called subtyping, and you'll understand what that means in a minute. Okay, multiple inheritance can't be done by extending dispatch tables. There would be conflicting tables. Oh, that's true of C++, right? However, multiple inheritance can be achieved by making the objects support multiple independent interfaces. Okay, so you wouldn't have an object containing conflicting interfaces, right? But you can have a single object that has conflicting interfaces, but you can take one or another, but not both at the same time. You see what I mean? Like you can have a 2D graphics engine, or you can have a 3D one, but you can't have both. Okay, now this subtyping is inheritance of interface. That's what that means. That's their definition. So the only form of inheritance that's of any relevance to com is inheritance of interfaces. That is, behavior, as opposed to subclassing, which is inheritance of implementation. You see? Because com doesn't care about implementation at all. That's not even in the picture. But in C++, this inheritance, when D derives from B, it acquires the implementation of all of the implementations of B's properties, right? D doesn't have to do that work, so it gains something. In com, if I want to inherit this object's interfaces, right, then I have to implement them. All I do is add more work for myself, right? the form of inheritance is in such a way that you inherit the responsibilities of being a bee, right? It's inheritance of responsibility, not you don't get and you don't gain anything by inheriting. Okay, everything derives from ion. OS kit, don't know. And then there's this query. We've seen it all happen. Now, the main point in this particular article that I wanted to go over, and I did in the other video, and I haven't yet in this, are some of the restrictions that COM places on interfaces and how and what they call well-defined some interfaces that are semantically well-defined. And these are requirements of COM. Four of them. There's probably there may be more, but there are these four: static, symmetric, reflexive, and transitive. Okay, you may have heard some of these words before. If a query on one specific interface, okay, so that means you have an interface and you're querying it to obtain a different interface. If that succeeds the first time, it must also succeed on every subsequent time. If it succeeds once, it must continue to succeed forever. Similarly, if it fails once, it must continue to fail forever. Okay, you can't suddenly start adding new features to something because it violates one of the principles of these COM interfaces, which is that they are static, they don't change. The interface for DirectX 2D is the same today as when it was first published. Of course, all of this is speaking of things that have been published and are out in the world and being used. Before that, of course, you can fiddle around, do anything you like. Once it's published, there's no changing. If you want to add or change something, you have to make a whole new interface. Okay, symmetric. A query on an interface for itself, the same interface, that should succeed, right? If you have an if you have an interface pointer A, and you query it with the same identifier for that interface, that must succeed. Now, reflexive is like commutative. A query on interface A for interface B, if that succeeds, then the reverse must also succeed. Okay? So if I query, an animal for appetite for something interface, then when I get an appetite interface, then a query for an animal interface from using an appetite. It should be the same. A word that starts with B. Anyway, it goes in forwards and backwards. It should be reflexive. And lastly, transitive. You probably have heard this word before. If you query A for interface B and that succeeds, and then B for C and that succeeds, then query on C for A must also succeed. So if A gives B, and B gives C, then C gives A. And because of the reflexive property, A also gives C. And that's true of things like greater than, right? If A is greater than B and B is greater than C, then A is greater than C. Although greater than is not reflexive, right? But it is transitive. It is transitive, unidirectional transitive. So that's another point that I left out. So I got circles here. Now, this is a kind of an interesting example. If you ever find this document, you might want to have a look at it. They started with this thing, and what they start out with is the idea that they're going to make a spaceship. Okay. Now, I don't know where this is first mentioned. I think I'm on page 2 or something. But anyway, and then they come up with it. They say we're going to invent a function called getObject. And the object in this case is the spaceship. So the class identifies the spaceship. And the spaceship may support interfaces. Okay, simple idea. The spaceship moves, so it may support the interface called motion. Alright, so it could derive from motion in C++. And then implement flying and getting the position. Okay. And the actual code is hidden away somewhere in the component part. That's what they call it, component object model. But this here is not COM. This is just regular C++. And here they're describing how you might extract the motion interface of the spaceship. There's only one ever, right? Unlike C++, again, going back to the picture, this picture has two objects already. COM has only one object and many interfaces, many ways of looking at the object. So here's the idea. It's very similar to the way it actually works. You have an identifier for the object, the one and only object, and identifiers for interfaces, the things that the object, the behaviors of the object. And if this succeeds, you get a pointer to the interface thing. Basic polymorphism, right? I put yellow around these. If you think of an interface as a contract between two software modules, there's no if. Think of an interface as a contract between two software modules. The idea is that interface declarations never change. That's the static. That's this part. If you want to upgrade your spaceship, you don't change iMotion, or iVisual was another one. Just display the ship. Instead, what you do is you add a new interface. Okay? So you never modify. Once these things have been decided on and published, they don't change ever. You can add a new interface. You could make an interface, a completely different interface that looks similar to one of these ones and adds more functions, but it would still be separate and be identified separately, and the previous one would still be existing and supported. It has to be. And this get class object is this is like create instance that I've been talking about, or we've been using. Create an instance, right? He's not going directly to com. He's making up a type of com, and he's called his created instance get class object, which is what create instance does. Think of this way of getting an object as a powerful alternative to the constructor idea. The ordinary constructor, you obtain a single object and one batch of member functions. With get class object, you get the object and a choice of interfaces. Okay, so there's a major difference there. It's kind of a subtle one, but just have a look at the way that they've gone about doing this. This might remind you, if you've been following this series, of when I was doing these, talking about programs that use the system tray, I ran into a little bit of a dilemma, and I wasn't sure what to do, because I wanted to have dialogues be able to use the system tray. That was one type, one class, and the regular windows that weren't dialogues, I would have liked them to use the system tray as well, but there may have been a conflict, and the way I solved that problem is very similar to the way that what they've done here for these interfaces of Spaceship. Instead of deriving from these interfaces, what the Spaceship thing has are internal classes, okay, that derive from the interfaces. Now it turns out, just like in the case of, if I can find it, the case of the system tray thing, which is in my common Windows, CS Windows. I've probably talked a long time. Where is that thing? The header is actually not there either. Let's fix this problem with the header. Let's see if I can find it. Now that was the system tray manager or something or other. Here. Okay, now what I wanted was to be able to use the same manager in two contexts, right? And so, but I didn't want to derive from it, in those two different contexts, because it was complicated and it wouldn't have made much sense. What I did was invented something called a container, right? The container is the outer class, the manager thing here, and inside this object, systman, is a pointer to the thing that contains it. And through that pointer, I can access everything through this pointer. I can access all of the members of the container. Including, well, let's see, what do I want to access? Here's the manager. Okay, I might want to get to this pointer of the thing that contains the object. Turns out that I can do that. I can do all of these things for a very simple reason. Okay, now here, there's a virtual function, right? How did that thing work again? Here's the, right, your window would be given, you would add, no, you wouldn't inherit from anything. You would declare not this thing, something else, this thing, assist man of some type. And the type might be a window or a dialogue. It's hard to see. Maybe the code. If we can find the code, might help. Okay, now this has died. Windows Systray Manager. Now it has its own thing that subclasses the window procedure of whatever it is contained in. And so it can intercept messages before they get to the, it might be a dialogue, or it might be a different type of object. It needs to know what the handle to window is of the container, and it is always able to retrieve this pointer of the thing that contains it, because it knows its offset within the struct. See, get this pointer for hwin. Now, if it happens to be this type, a systray dialog, I know that in the user data area, there is a pointer to a systray dialog, right? That's the main class, the outer class. And from that pointer, I can obtain the pointer to the manager thing, which is what this thing is. It can find itself, basically. Now, that idea that it can find itself because it can find the thing that contains it is the same principle that's used here. These things know their relative offsets with respect to spaceship. So, an iMotion interface knows where it is in the struct, and it also has, because of the friend declarations, it has access to all of the members of spaceship. So you can take an iMotion interface and query it for an iVisual interface. Because it knows where it is, it can access all of the members of the thing that contains it, And one of those things is an iVisual. So from one interface you can retrieve out of the spaceship another interface that's completely unrelated. And that's what they do in MFC. They have a macro called method prologue, okay, and that creates a this pointer to the spaceship, and that allows access to the spaceship's members. Okay. The method prologue thing is an NFC macro that uses the C offset of operator to retrieve the offset used in generating a this pointer to the parent class be this. And the compiler always knows the offset to the parent class to the data of the nested class, and so you can navigate your way around the object and pull out other bits and pieces of the object through that mechanism. It's the same thing that I was doing with that system tray manager. Very similar. See, that's what it's saying here. Once the interface mechanisms are hooked up, the client needs to get either an IUnknown interface pointer or a pointer to any one of the derived interfaces. Okay. Another thing is that the COM standard demands query interface return exactly the same IUnknown pointer value for this particular interface, no matter which interface pointer you start with. So that's that IUnknown is unique to the class. The class in this case is a spaceship, right? The container, the main thing, right? In our case, it's a math object. Here it's a spaceship. There is a property that is global to the class, such that is this property that whatever interfaces the class might support, if they are queried for an interface using just IUnknown identifier, then you should always get the same pointer back. So if two IUnknown pointers match, then you know with certainty that those two interfaces are belonging to the same class. The same class identifier, the same DLL, same spaceship, same math object. That is, that IUnknown, that particular one, sometimes known as the void star of COM, because it represents the object's identity. Now that's what I've talked about. I haven't shown you any code or anything. But see now that it goes on now to talk about factories and how the way to achieve all of this is through the factory mechanism. But I've used too much time, and I guess I'll leave this here for some things for you to think about. And this document, this might be the name of it. How would I find that document? Could be my history. This was quite a while ago. But I haven't cleared it out. recently. Through all the porn sites and stuff, I'm sure we'll find it. Let's see now. It's today. Cat. Oh, why don't I do a search? Will this search? No. I was just trying to find something on the basic level. Oh, all of these have com in them? Oh, .com. Good God. Okay. Check my time. That's long. Okay. But I think I'm not following it. Okay, this is this one. But that's on kids. It's something 23 something. DOM document outfit. Yeah, that's great. I don't know. What was it? Visual decon maybe. I don't want to look at decon. It's too complicated, but it's. If you find an article on decon, there might be an intro on more basic stuff. Decon, that means dynamic. Content not found, sure. No, probably searching. Oh, I searched for some of these pictures. I don't know. Oh, wait a minute. Here's some. Okay, here's that one, the 4 thing. So you can see that there. I'll try to include it in the description. Oh, I hate that. I hate that. You gotta click on it. The only way to get there is to click on it. OS Kit, Chapter 4. I guess there's more chapters. As soon as I search for PDF, I'm pretty sure. Ah, here it is. Okay, so I got that. So I'll let you have a look at those on your own. It actually has that same silly name. I'll include it in the description, just to give you a better idea of what we're talking about before going on to the experiment that I'm going to do. I'll tell you about that because that might keep you interested in what's going to happen next. One of the things I discovered, you remember when I was doing the virtual function stuff and virtual function tables and so on, I invented a function that could tell you how many virtual functions a thing had, right? And then we found out how we could find the virtual function table. Well, it turns out we can do the same thing with COM, at least this type of COM. And it turns out that the first function in the dynamic dispatch table for any given interface is the query interface function. That's always the first one in the list. And I developed this algorithm for determining, given a COM pointer, you have to be careful. If you pass a real COM point, if you try to pass a COM pointer to this, it does a non-trivial cast. It's not a reinterpret. P-void works. If you take the pointer, your interface pointer, add 8 bytes, dereference it, add 8 bytes, dereference it again, then that pointer points at the dynamic dispatch table, and the first entry is the query interface function for that particular interface. Okay, so what I want to do is use this to walk through all of the COM objects members, see how many there are, and see if we can call square and cube using this. It should work. We should be able to cube a number by just knowing, just taking our interface pointer and finding the offset. We know what the offset is of each of those functions, and so we should be able to call cube by calling the fifth function. And we know how we're supposed to call it. It's right to left pushing, so we push a pointer to a long, and then we push our interface pointer, that's the this pointer part, and then it's a standard call, and it should work. No reason why it shouldn't. Okay, see you.